to look at something that we're all fairly familiar with, and that is the Pythagorean Theorem. When we want to measure distances, like across water or anything like that, we have to remember that maybe we can't physically measure them, okay? Maybe we have to use some geometry. Now, many of us have heard and may remember this formula, the Pythagorean Theorem, and what it says is a squared plus b squared equals c squared. The biggest thing to remember is that c squared is our hypotenuse. It is always our longest side. A and B, it doesn't really matter which order we use those in. Those can be used interchangeably, but C has to be our longest side. Now, another thing that we have to remember is this must be a right triangle. If it's not a right triangle, meaning if it doesn't have a right angle here, then we can't use this, okay? We have to use some other different formulas. And so with this, we can solve to find these missing links. So say that I know this side and this side, the distance here and here, but I want to find this side. So the length of the side across from the right angle is always your C. Now, please remember, whatever you're looking for is not always your C. Your hypotenuse, the longest side, is always going to be your C. So the side across from that right angle is always your C. Again, these two sides can be used interchangeably as A and B. So if I set this up, it's going to look like x squared plus 5 squared is equal to 8 squared. Now, if I do a little bit of algebra to solve this for x squared, I can subtract my 5 squared from both sides. Let me go ahead and, because remember, what you do to one side, you have to do to the other side. And that would leave me with x squared is equal to my 8 squared minus 5 squared. And then to get rid of a square, we take the square root of both sides. Okay. So I get x is equal to the square root of 8 squared minus 5 squared. Now please be careful. Yes, that square root got rid of the square on the left-hand side. That square root does not get rid of these individual squares. I have to solve for this entire side and then take the square root. Okay? So in other words, c squared up here, I can solve this, and it would look like c is equal to the square root, not c is equal to. I could have that b, or a, is equal to the square root of c squared minus a squared. So in other words, a side is equal to the square root of my c squared minus my a squared, or vice versa. Basically, side is equal to hypotenuse squared minus my side squared. That's another way of writing it. So a squared is 64. I'm sorry, 8 squared is 64. 5 squared is 25. And I don't want to forget my square root. So 64 minus 25 is 39. So this right here is actually your exact answer. So x is equal to square root of 39. It can't be broken down any further. I'm going to show you one in a moment where it can be broken down. So this is an exact value. Your approximate value if I were to take the square root of that, would be approximately 6.24. Now, if I had done this a little bit differently, let's look at it if I had done this. Let me kind of go through here and erase all of this, and I will show you that I get the exact same thing if I solve things first and then move them, okay? Because it does come out the exact same way. So let's say that I have, again, x squared plus 5 squared is equal to that 8 squared. Okay, so x squared, 5 squared is 25. 8 squared is 64. Well, I can't do anything with that x squared yet, so I subtract 25 from both sides. And so then I get that x squared is equal to 39. And I take the square root of both sides. X is equal to the square root of 39. Same answer. Okay? You can either solve it down first or whichever way you prefer. Doesn't matter. They both come out to be the exact same thing. Okay? Now, let's think about this second triangle here. Which side is my hypotenuse? Well, again, here's my right angle. So the side across is my hypotenuse. So that means that x is going to be my hypotenuse. So I have 16 squared plus 28 squared is equal to x squared. So 16 squared is 256. 28 squared is 784. That's equal to x squared. 256 plus 784 is 1040 is equal to x squared. I take the square root of both sides. I get 1040, square root of 1040 is equal to x. Now, this can be broken down. Remember I said that 39 could not be broken down. Here's what I mean by 39 cannot be broken down. 39 is the same thing as 3 times 13. 3 and 13 are both prime numbers. Neither one of those can be broken down any further. I don't have a pair of either one. In order for something to come out of the square root symbol, I have to have a pair. Think about the square root of 25. Well, that's 5 times 5. So I have a pair. Square root of 25 is 5 because I have a pair of 5s. Here, I don't have a pair of anything, so I can't break it down any further. 1040, I can break down further. You can start, and if you don't know what you can break it down by, think about it. Okay, I can break it down by 10. It ends in a 10, in a 0. So I can do 10 times 104. Okay, well, I know that 10 is 2 times 5. Okay, 2 times 5. 104, let's say, divided by 2 is 2 times 52. Well, 52 is even, so I'm going to divide by 2 again. So that's 2 times 26. And as I divide down, I'm going to mark out what I've broken down. 26 divided by 2 is 2 times 13. So notice now I have 1, 2, 3, 4 2's. I have a 5 and I have a 13. So I have, here's one pair of 2's, and here's another pair of 2's. They get to come out as partners. Gotta have the buddy system, gotta have a pair. So 2, this pair comes out, and then I'm going to show you that this pair comes out, and then these have to get multiplied back together underneath. So 2 times 2 is 4. 5 times 13 is the square root of 65. That would be my exact value. Now, it really doesn't matter what you start with when you start breaking these values down. Let's start with, let's say I started with something a little bit higher, or maybe a little bit lower. I start with 16. 16 times 65. Okay, I know that 16 is 4 times 4. 65 is 5 times 13. Oh, well, I have a pair here, and neither one of those can be broken down. So that's 4 square root of 65. I get the exact same answer. It doesn't matter how you break it down. You can either break it down all the way to its prime values, or you can break it down into something that gets you a square root. You should come up with the exact same thing as long as you've broken it down as far as you can. Because if I were to keep going with this 4 and 4, notice that 4 times 4 is 2, and then 2 times 2. So I still end up with 2 sets of 2 that go on the outside. It still breaks down into the same prime factors when you're working with radicals. Okay? 4 square root of 65 is the exact value for x. The approximate value would be 32.25. Now, we have a converse of the Pythagorean Theorem. And that says if triangle ABC is a triangle with sides of length A, B, and C, such that a squared plus b squared equals c squared, then triangle ABC is a right triangle with the right angle opposite the side of length C. So if you have any right triangle, or any triangle, and you can solve and get a squared plus b squared equals c squared, that is a right triangle. Whether you're told it is or not, it becomes a right triangle. Now remember what I said about C, it is always the longest side, that hypotenuse. So I want to see if these 3 sides could be a right triangle. Well, 2, 3, and square root of 13, I don't really know what square root of 13 is. Well, it's approximately 3.6. So it's my longest side. So I look at 2 squared plus 3 squared equals the square root of 13 squared. 2 squared is 4. 3 squared is 9. Square root of 13 squared becomes 13. 9 plus 4 is 13. That does equal 13. This is a right triangle. Try this one. 3 squared plus 4 squared. Does that equal 7 squared? 3 squared is 9. 4 squared is 16. 7 squared is 49. 9 plus 16 is going to give me 25. And that does not equal 49. So no, that's not going to be a right triangle. Now this last example is looking at two cars departing from the same house. So here's our house. One drives south at 50 miles per hour, and the other drives east at 60 miles per hour. At 8 p.m., how far apart are they? So at 8 p.m., we want to know this distance. Well, since they're driving south and east, we know that this is a right angle, and so that is our right triangle. They're driving at two different speeds. 5 p.m. to 8 p.m. is 3 hours. So 60 miles per hour for 3 hours means that this person should have traveled 180 miles. 50 miles per hour for 3 hours, this person should have traveled 150 miles. We want to know what this length is. 150 squared plus 180 squared equals x squared. And we solve. So we get 32,400. Oh, nope, wrong one. That is 22,500 plus 32,400 is equal to x squared. That gives us 54,900 is equal to x squared. So you get the square root of this. 54,900 is equal to x. That's our distance. And I'm just going to say you can approximate that. It will be approximately 234.3 miles that they are apart. So try using the Pythagorean theorem now.